Welcome to Introduction Video Security System, VSS Fundamentals, brought to you by Pelco. This course is a guide to the basics of any video security system. This section is an introduction to camera lenses. Selection of a lens is critical because it directly affects the size, shape, and sharpness of the image to be displayed on the imager. Factors such as distance from the scene, focal length, desired field of view, lighting, and format affect the size and clarity of the image. At the end of this course, the learner will be familiar with the basics of a camera lens. At the end of this section, you will be asked to complete a few assessment questions. A lens gathers available light and focuses the resulting image on the CCD chip of the camera. Typically, the more light that passes through the lens, the better the quality of the picture. Lenses come in many sizes, focal lengths, and iris features. The role of the iris is to adjust the amount of light passing through the lens. There are three basic iris types: no iris, manual iris, and auto iris. There are two forms of an auto iris lens: DC-controlled iris and video-controlled iris. An f-stop is a parameter used to measure the capability of a lens to collect light. The f-stop rating determines the speed of the lens. The higher the f-stop setting, the more loss of light. Each increase in the f-stop number will close the iris by 1/2, thus decreasing the amount of light reaching the camera's sensor by a factor of 50%. The viewing angle of the lens, or how wide an area the lens will see, is measured in millimeters. This number is found on each lens. It is often most cost-effective to match the lens format to the camera sensor size. It is possible to use a larger lens on a smaller size camera, since the image only needs to be at least as large as the sensor. Using a larger lens can often be advantageous, since it offers greater depth of field. The range of distances from the lens before objects are too close or too far away to be in focus. Larger lenses also mean that the area of the image that is used is taken entirely from the central, flatter part of the lens, causing much less corner distortion and better focus. It is not recommended that you use a smaller lens on a larger size camera. This illustrates the formulas for calculating a lens. Initially, you could never place a CS mount lens on a C camera. It would mount properly, but the camera lens assembly could never be focused. To alleviate this problem, cameras are now made with built-in conversions between C and CS lenses. Smaller solid-state camera formats, 1/2 inch, 1/3 inch, 1/4 inch lenses have changed. The normal lens used was known as a C-mount type.